in the previous video, we looked at processing and analyzing the incoming stream of video to apply effects and to, for example, track the brightest pixel or perform background subtraction. And these are all things that is part of computer vision. And when you start getting into computer vision, you will quickly come across the OpenCV, or the Open Computer Vision Library, which is simply a set of libraries containing well-tested, tried and tested algorithms for doing this kind of thing. For example, if you want to track movement in a stream of video, if you want to identify faces in still images or in video images and track them, if you want to do edge detection and all kinds of other things, then you will find OpenCV to be very useful. So there are a few wrappers that allow you to use OpenCV in processing. OpenCV itself is written in C, and so in order to use it in Java, which is what processing is, we need to use some special classes that kind of wrap up that OpenCV code. So let me give you an example. Yeah, well, it's not particularly up to date, but the best sort of wrapper at the moment seems to be OpenCV-processing, which you'll see the link for that in the slides. And here is some code that gives you an example of what you can do with this. Let's run it first to see what it does. So, as should be pretty apparent, it's a face tracking module that simply draws a box around any face that it finds in the frame. I don't have any other faces handy at the moment, so I can only show you one, but it will track multiple faces at the same time if you want it to. And there's hardly any code to this really, where we're just using all the functions that the good people of OpenCV have already provided for us. But you can see here we're setting up our video camera. We are setting up an OpenCV object, and we're telling it to use a particular method to track the face, and then we're simply going through all the faces that are detected in the frames of video as they come in, and drawing a rectangle around those locations. I think I have another example as well here to just give you a sort of a flavor of the kinds of stuff you can find in OpenCV. But if you Google it, you will, of course, find a lot more details. Suffice it for this subject, it's sort of sufficient to know that the library exists and that it has a lot of very powerful image processing algorithms in it. This is an edge detection algorithm that we're applying to the live stream of video. And we actually we touched on some edge detection in the lecture, in the videos, and the discussion last week. But what you can see here is on the top left, the live stream of video, and then in these some other images, various sort of different approaches, different algorithms for detecting edges in the video. So you can sort of see the effect that those different algorithms have. And depending on what you're wanting to do with your live stream of video, whether you just want a visual effect or whether you want to start analyzing things and maybe trying to identify objects or count objects in a scene or something like that, you might use edge detection and background subtraction perhaps together to try and do that. We're not going to go in depth into that in this subject because we don't have time. I'd love to, but we don't have time. But I would at least like to point out that these things are available for you. And I also wanted to say, and let me just bring up my video again so I can see you all. I also want to say that OpenCV is huge and extremely powerful. So if you need to do some image analysis or some kind of image tracking, like face tracking or edge detection and stuff like that, take a look at OpenCV first, because you'll find there very powerful, very well-tested algorithms implemented in ways that are most likely going to do a better job than what you'll do if you try and naively hack it up yourselves. I'm a big fan of naive hacking, of course. That's great, and it's a great way to learn. But if you want to get the job done in as little time as possible and with as little, fewer bugs as possible, you really should be checking out OpenCV for that kind of stuff. So that's all for this week. Hopefully by now you understand how to play and manipulate video. You can read and display live video coming from a webcam or something like that attached to your computer. Hopefully you've got a very sort of understanding of the very basic concepts of video analysis, and you have a sense of where these techniques, how these techniques are applied. You can see how we can access individual pixels using processing, and how we can do simple little analysis, simple little tricks like analyzing and finding the brightest pixel in the scene and tracking that as it moves around between frames of video, for example. So you get a basic concept of how video analysis and motion tracking kind of works at a basic level, and you hopefully have a sense that there is OpenCV, that is a very powerful library for doing very sophisticated image analysis. And you should also hopefully get a sense that image analysis is a very active area of research with a lot of smart people working in this area. So there's some very exciting things still to come out of that area, I think, especially with machine learning techniques and things being applied to this as well. That's it for this week, and I will see you in class.